So next topic is frequency division, multiplexing and demultiplexing. So that is FDM. Now let us see the code. Here two DSP signals are generated with different carrier frequencies and they are added. So that is FDM is combining all modulating signals. So that is multiplexing. So demultiplexing means from the combined signal, and we have to separate the DSBC signals. DSBC signals. Now how it is done? See here. So clear all and close all. So F1 is equal to input carrier frequency, input baseband signal frequency. F2 is the another baseband signal frequency, and carrier 1 signal frequency, and second carrier FC2 is the take the input from the second carrier frequency to generate second DSBC. Okay, so T is created, T column matrix is created with T equal to 0 colon 0.001 up to 0.4. So T0 is initial value and 0.4 is the maximum value of the last element, and 0.001 it is the incremental value. So it creates a column matrix of T. So M1 is equal to cos of 2 pi F1T, it is the first message signal, and M2 it is the second message signal cos of 2 pi F2. F2 is the frequency of the second modulating signal, second message signal, and T is substituted. So M2, M1, M2 both are two modulating signals, message signals. Similarly, so C1 cos of 2 pi FC1 into T, and C2 is equal to cos of 2 pi FC2 T. So C1, C2, both carrier signals. Okay, first you have to generate DSBSC1. So DSB have to generate DSBSC. So by multiplication of message signal 1 and carrier signal 1, first carrier and first message signal, so it produces AM1. So that is a DSBSC 1. So second DSBSC, you have to multiply second message signal with a second carrier signal, that produces AM2 DSBSC 2. So both are combined. FDM signal means both are combined, M1 plus M2. So that generates FDM signal. So FDM contains two signals. So DSBSC1, DSBSC2. So why it is DSBSC? In case of DSBSC, message signal is multiplied with carrier signal. So that is nothing but DSBSC, double sideband suppressor carrier. Okay, this is DSBSC1, this is DSBSC2. So two signals are added and that are stored in the FDM variable. So FDM variable contains the FDM signal. Okay, now we have to separate so AM1 and AM2 from the FDM signals. Now we have only FDM signal. So now let us see how to separate DSBSC1 and DSBSC2. So this is what FDM signal spectrum. So first message signal is modulated. First message signal modulates the first carrier frequency FC1. So this is a DSB1 spectrum. So it is having LSB and USB, and second DSP contains LSB and USB, center frequency FC2. So see the limits of the bandwidth of the DSP-SC1. So DSP-SC1 bandwidth is, so FC1 minus FM1 is the lower frequency, and FC1 plus FM1 is the higher frequency. So you have to select the band pass filter with the limits of FC1 minus FM1 and FC1 plus FM2. So lower cutoff frequency and upper cutoff frequency you have to select in this way. Then we can separate DSBS from the FDM. Similarly, so you can separate a DSBSC2, so with the following BPF cutoff frequencies. So you have to pass through the band pass filter, so having the cutoff frequency FC2 minus FM2, one lower cutoff frequency, upper cutoff frequency is FC2 plus FM. You have to take another band pass filter having the cutoff frequencies, lower cutoff frequency of this one, and higher cutoff frequency is this one. Okay. So in this program we are not using band pass filter. So we are using Butterworth high pass filter and low pass filter. High pass filter and low pass filter. So high pass filter having a cutoff frequency, you have to take lower limit. This is high pass filter cutoff frequency, so it should be a lower cutoff frequency, FC1 minus FM1. So this is the pass band of the high pass filter. Similarly, you have to take the low pass filter. So having the cutoff frequency FC1 plus FM1. So it is the lower cutoff frequency. So what is the common area we have observed? So what is the common area we have to observe? So common area we have to observe the common pass band. Okay, so pass band is from lower limit to FC1 minus FM1. So FC1 minus FM1, and common point, common band. So FC, take the common area for HPF and LPF. So you will get the limits. Okay, so limit is FC1 plus FM1 and FC1 plus FM1. Okay, so this is the FC1 minus FM1. Sorry, so it should be FC1 minus FM1, and the second limit is FC1 plus FM1. So you will get band pass filter like this. So in the program we are taking Butterworth high pass filter and low pass filter with the cutoff frequencies FC1 minus FM1, and taking LPF with cutoff frequency FC1 plus FM1. So due to by taking these two, HPF and BPF, we obtain band pass filter. So with the cutoff frequency, so FC1 minus FM1, here FC plus FM1. So with this limit, so this is the spectrum range of the DSB-SC1. So similarly, same to take HPF and LPF for second message signal, for second DSB to detection, Now let us open the program. Okay, so separating DSBSC1 from the ABM signal, so you have to call the Butterworth filter, high pass filter. So with the frequency limits FCH, FC1 minus FM1, and low pass filter cutoff frequency is FCL equal to FC1 minus F1. Okay, FC1 plus F1, so FCL minus F1. So this is higher cutoff frequency of the high pass filter, and this is the cutoff frequency of low pass filter. You select this one. So call butter function with these arguments. First argument is order of the filter, second one is normalized with angle of frequency, and third is high pass filter, indicating high pass filter, and pass call the filter function, and input is a BM signal. Again you are calling butter function for low pass filter. Again you are calling filter function. Final rate M12. So M12 is nothing but the demodulated signal. M12 is nothing but demodulated signal of DSBSC1. So modulated signal. So modulated signal. It is a DSBSC1. So modulated signal. For demodulation, again you have to multiply M12 with carrier signal. So this is the product modulation. So M11 is the product modulator output. Product modulator output, if it is passed through the low pass filter, passed through the low pass filter, but with low pass filter, finally you will get so BA11. So it is the demodulated signal BA11. If passing through to whatever the low pass filters, BA11. The same thing is for separating the DSBSC2 from the FDM. First of all, you have to call high pass filter. What was high pass filter? So call filter and filter function, and call Butterworth low pass filter. So it is low pass filter, same as in DSBSC1. You have to call high pass filter and low pass filter. So finally we will get AM22, that is DSBSC2. So you have to demodulate the DSBSC2. So how to demodulate a DSB signal? By using product modulation. Product modulation means DSBSC signal must be multiplied with carrier signal. So that is M21. So that is M21 is passed through the Butterworth low pass filter. So you have to call butter function to get the denominator to numerator coefficient, and you have to call function filter 2 times after passing through the 2 Butterworth filters. So finally you will get BA22. So that is the final output of the second DSB signal, demodulated signal of DSBC2. So BA22 contains the demodulated signal of DSBC2. Now you have to call subplot 3, 1, 3 figures. First one is FDM, second one is demodulated signal M1, second one is demodulated signal M2. So this is what demodulation of FDM signal.